What? The quality of the maps provided by OpenStreetMap or by Google or by Bing is of course extremely high. You all know that from using your smartphone, navigating yourself in a car or on foot in a town. So we zoom in a little bit to Santo Domingo and you can see every restaurant, every pharmacy and every shop, and it's really up to date. And of course, that's the aim of these maps, is helping people navigating themselves inside towns and on roads. But when dealing with historical research questions, these maps are not the thing we are looking for, because they're displaying the world as it is. But what we need are maps displaying the world as it was in the time our research focuses on. So we need to incorporate old maps which are scanned or printed or photographed. So I can just drag and drop an old map and I zoom on it, and you can see now we have a historic map of Hispaniola inside our GIS system. And if you zoom in, you can see the quality of these maps can be quite good, depending on the quality of the map itself and of the scan, of course. But the problem is, if you use this tool, the measure line tool, and we measure a little bit, you can see that is definitely more than 300 meters. So the scale of the map is not right. And if you zoom out a little bit, we see another problem. That is definitely not the position where you expect Hispaniola. Another indication for it is the question mark, which is displayed here on the right side of our layer entry, indicating that it doesn't contain any coordinate system. Therefore, we need to start a process which is called georeferencing. First of all, kick it out again, right click it and go to remove layer. You have to click OK again. And now you go to layer and to georeferencer. A new window will open, and with this box, open raster, you can now open the Haiti map, and now it will display it also in this window. What we need to do now is to start a process called georeferencing. Now we need to click on pixels here in our scanned raster map and to combine them with real-world coordinates from our GIS. That's actually quite a quite easy process. So you need to take care that this window add point is activated, and we might start in Santo Domingo, maybe here. Now you could enter data directly if you have the coordinates, but that's of course a cumbersome process. So we use the option from Map Canvas, and now you will be directly led back to this interface. And now we're going to Santo Domingo, and of course now it's difficult because the scales are so different of the two maps to find the right point to click on. But as the other map is not really detailed, I just click somewhere here in the middle of the town and click OK. Now we're going to click a next point. We're going to use Port-au-Prince again for Map Canvas, and we're going to Port-au-Prince. Click OK again. And I would recommend to do it for at least 10 other places here in the in Haiti, and that depends a little bit on the age of your map. If you have a quite new map which is made with modern surveying techniques, 5 to 6 point might be enough. But if you have old maps, which is quite distorted and need to be stretched out in several directions, more points are always recommended. Because it might be boring for you now to follow me finding all these places, I will make a small cut here and I will come back when I'm done with entering my 10 points in the map, so we can proceed with it. So as you see, I now distributed 14 points quite evenly around the coastline of Hispaniola, and that's really the way you should do it. Distribute them evenly and take as much points as you can or as you want to make it more accurate and more precise. Next thing to do is to set up our transformation settings. First, you need to set a transformation type. These are different algorithms which can be used to do the transformation from our map to a geodata set. Linear, Helmut, Polynomial 1 are not really well suited for our task because they're just able to scale, rotate and move our map, and as our map, our old map, as the most old maps, is highly distorted, that wouldn't be simply enough. Actually, every map which is scanned is distorted in some way, so linear and Helmut and Polynomial 1 are never really well suited for a scanned map, and it just can be used by very modern maps which are digital born and digitally given to you. The three algorithms which are interesting for us are Polynomial 1, 3 and Thin Plate Spline. It's always a little bit different which one is the best one to choose, but I must say in the last years I had the best results always with the Thin Plate Spline. It recommends more points because the map can be changed in more different ways, but it will in the end produce the best result. And I would recommend you, especially with old maps, to use the Thin Plate Spline algorithm, keeping in mind that you might need a little bit more points than you might need with the Polynomial 2 or 3 algorithms. So choose it. Next one is a target coordinate reference system. I don't know what it's now in your window, maybe it's even empty. So please click on the small globe, select coordinate reference system, and here you have long lists with all the coordinate systems available. But as the most worldwide web-based services like Bing, Google or OpenStreetMap use the same coordinate system, which is called WGS84 Pseudo-Mercator. You just simply choose this one because our ground laying data set is already in this one. And to look for it, you could try to type the name, which is not the best way to do it, but they all have a specific ID. And you just can type in this ID. That might seem a little bit strange, but if you deal for some years with GIS, you know many of these numbers without having to look for them. And they're always clear, so you can't make any mistake. So now you have to choose it here, and you can see it's valid worldwide. I will just click onto this one just to show you these red boxes just show you where the coordinate system is valid. So this one is a North American datum coordinate system and it's not valid worldwide. So if we would choose this one, we will produce a big mess, and this one is valid for the whole world. And in one of the next steps, we need to transform it to a coordinate system which fits Hispaniola much better. So, but for now, we leave it here. Press OK. So resampling method, we will use cubic. We also could use nearest neighbor or linear, but these two are more meant for cases when you need to preserve every pixel, but we are looking more for a better quality of our image. So I would recommend to go for cubic. Compression, please choose no compression, because we will lose quality, especially if we need to transform our image again. We leave it like it is, even if it now produces a quite big data set. The rest you can leave like it is. So again, transformation type should be Synplate Spline, target CIS is EPSG SV857, output file name, oh, we forgot that one. You can leave it like it is. It will just add modified to your original data set, and as we need to retransform it, we can leave it like it is, and we'll give it a fixed name in the next step. Resampling, method cubic, compression like it is, and I press OK. Now we can press this button, which is called play. Now it will take a while, depending on the quality of your computer. Now it will state georeference successful. You can move that away, and now you can see it is now on the right position. And to check it, you can change the transparency of the image we just georeferenced by choosing it. Going to the layer styling panel, if it's not switched on, again, right mouse button, panels, layer styling panel, and here's a second entry in the menu is global opacity, and you just can make it transparent. And now you can see the black line is the coastline of your georeferenced map, and the other one is the actual coastline, how it is displayed in the OpenStreetMap service. Of course, now you can see you have quite some errors in the map, and it's definitely mostly driven by the age and the ground-lying survey technique of the map, by the quality of the scan. But basically, you can see it worked quite well. And if you work on a large scale, let's say a Hispaniola scale project, it should be really possible to work with it now. Some hints: you might have problems like this, where you can clearly see it's just all a little bit too far in the south. Then you might go back to your georeferencer window and to set some more points here in this region, and it might fit a little bit better when you press play again. But that can be different in all the different cases you might use it for. That's a quite complicated topic, and if you go for a really old map, you will get much more problems georeferencing it. And then I would recommend other techniques to get the data out of it. And we also will talk about that later on. That should be everything for now when it comes to basic georeferencing of maps. And in the next steps, we will see how we digitize and analyze features which are contained in that old maps.